Okay, and we are about to go live on the stream as well. Okay, great. So the stream is also live. I want to greet everyone in the community. Hello, everyone. We have Bernard today with an interesting topic about GitOps. We have right now plenty of people in the stream. So it will go like this. We will have people in the stream. Bernard will give a presentation, and feel free during the presentation to post your questions, suggestions, whatever, into the chat. Make sure to stay until the end, because at the end there will be a raffle of 10 prizes, 5 t-shirts, and 5 different coupons, which were nicely provided by Bernard. And yeah, feel free to post here in the chat where I'm from, which city, which country. I'm tuning in from Germany. Bernard, hi, where are you from?
Hey folks, I'm tuning in from a small town called Trenčín in Slovakia. It's actually a very nice place, so if you're coming by, give us a shout. And I think we can start, right, Karen?
Yeah, if you want, Bernard, you can just say a couple of words about yourself. What's your occupation? What are you doing in nice Slovakia? What's your business? A little bit about yourself.
Right, so where I'm coming from is, yeah, I've got a couple of years over 10 year long experience. I have been through development roles at the very early stage of my career, and then I moved into the more like IT operations side of things. And this actually somehow predefined me to to enter the world of what we call now DevOps, right? So I think I'm a person who can talk and understand developers, build automation, and definitely you guys can discuss with me, firewalling, networking, routing, stuff like that. So I'm really sitting on top of sort of both worlds.
Yeah, that's great. Mm-hmm.
So
Go on.
what I currently do is we have a small company in consultancy business in here in Slovakia. We are remote, and what we assist the clients with are exactly the topics around DevOps. So that's Kubernetes clusters, through and through. That's the cloud infrastructure alongside of that. That's the integration of all these into the client's premises, into their environments. That's building CI/CD pipelines, those typical kind of things. And GitOps goes really well with these topics, and that's how we, explored this topic and try to understand how it can help us and provide the value to our clients.
Mm-hmm. Yeah,
So
that's really great. Where are your customers are actually like mainly from? Are they also from Slovakia, or are they also from across the world?
we had some clients in Slovakia, but it was quite long ago. So mainly we have clients from within Europe. The portfolio is mostly enterprises, but we do have some smaller startups or scale-ups as well. The demanding clients are actually enterprises from the experience. Typically, the complexity goes a bit deeper with the enterprises. Yeah, it's like two different worlds, right? The startup wants to move fast. The enterprise wants to make sure that everything fits, nothing will break, and everything can be planned and migrated smoothly and governed and under control. Yeah, so we experienced both.
That's really interesting, so that we know what the target businesses actually like for this kind of technologies. And obviously these are enterprises, like middle and big enterprises usually, not so much small businesses. Some startups, yeah, as well, also from our experience. But as you said, that's pretty much like the target group here we are talking about as customers. Great.
And what's interesting is that well, maybe we will conclude that at the end of the presentation or at the talk, is that I truly believe that GitOps fits everywhere. Like no matter whether we are talking about enterprise, startup, or scale-up company, I can't imagine not doing GitOps for any type of these clients.
Mm-hmm. Okay, that's a great term actually to start with. And I don't know if you in your presentation going deeper and telling us about the GitOps buzzword and what's behind it, or if not, you can also maybe shed a little bit of light, like what is actually GitOps and what's the difference between DevOps and GitOps. But again, if it's a part of your presentation, then let us jump into it. Otherwise, you can just elaborate a little bit on it.
So I'm going to share the screen because this is the very early of the presentation itself. You know, the first two
That's
slides.
great. That's really nice. Very convenient.
Perfect. All right. So what's the true focus of the presentation? It's lessons learned around GitOps. You know, how to avoid failures, what to expect for the people who are not there yet. And then the second part is a Flux Cd tool. This is like typically one of two tools when people talk about GitOps. They ask about, okay, how you achieve it. So that's either with Flux when talking about Kubernetes or with Argo CD. And then there are lots of, comments on Reddit threads saying which one is better, which one is more suitable for which purpose, and so on. So I chose Flux for the talk because I just have more experience with Flux. That's the main reason. So I did the introduction. I'm gonna skip this part, and I'm gonna just give you a rough idea. We will at the beginning talk about the infrastructure as code. It's a prerequisite for GitOps. Then I'm gonna spend a minute or two explaining like where we were before we embraced GitOps. What were the challenges that we faced? What were the problems? And it was not like that we were failing miserably or anything like that. But when we just came across first articles and blog posts about GitOps, it really clicked. Like this is what we need, right? And I'm going to talk about Flux a little bit, give you an introduction. I have a small demo prepared. There is a specific part that I would spend a minute or two as well, and that's secret management within Flux, especially if you're interested to store the secrets on your Git repo alongside, for example, Kubernetes manifests. And yeah, towards the end, the typical things like where there are probably the borders of GitOps, like how far shall we expect this to go reasonably well, and maybe there are some areas where you might not want to go with this approach, and there are other concepts better suitable, right? Okay, so the infrastructure as a code, as I said, this is a prerequisite. If we just look at the term GitOps, so what we see Git as the version control system. We see ops as IT operations. The concept evolved from infrastructure as code. What that means is that we have a Git repository where we have described our infrastructure, It can be infrastructure on lower level or on higher level. It can be cluster configuration. It can be Terraform, many different things. But the true thing is we store all this in a Git repository as a single source of truth. And on the other side of things, we've got the target system that we want to configure. And in order to make this happen, we need to have an automation that translates the content of the Git repository, the configuration, and applies the configuration on the target system. There are some prerequisites. So Git really should be the single source of truth. You don't really want to have multiple sources of truth colliding on the configuration of your target system, because then you get a couple of problems that, for example, what the system looks like today might not be the case tomorrow, right? It can change over time without you changing anything. And second thing that we need to be aware of in order to make this happen is that the provisioning automation or the configuration automation, it has to be idempotent, meaning if I run my automation today, it should yield the same results tomorrow or day after tomorrow if the configuration in the code is the same, right? So unless the code is changed, the automation should always produce the same result if applied over and over and again and basically forever, right? So why did people come up with the infrastructure as code is that there are a couple of advantages going down this way. So from the software development world, peer reviews. If you've got a decent culture in your team, peer reviews are going to help tremendously. They help in software development processes. They will help pretty much the same way in infrastructure as code sort of based IT operations. I mean, life, well, true experience is that we caught lots of problems by doing peer reviews on our infrastructure code. So, totally go for this one. Consistency, I have mentioned. You need to make sure that you are building constantly the expected configuration, no matter when you run it, how many times over. Another thing why this is the way to go, and I really can't imagine not going down this way, is the visibility this approach gives. So, you commit the code to the Git repo. Typically, there is some person, so auditability. There is a person assigned to the PR, the creator of the pull request. There is some description, why it happened, what has been done, how was it tested. And of course, if you're doing small changes, you will probably take these slightly on a lighter side of things. But if you are doing big modifications, you typically put a bit more effort into the content of the pull requests, and then you can trace back. Like, okay, you find on a cluster that there is something odd. So okay, you have a look into the Git repo and you trace the change back and you get the context. Amazing stuff, right? Machines, like the automation put in place, also yields to less human errors. This is obvious. I think this is pretty much a no-brainer. An advanced concept that can be built on top of this is that imagine that you build your automation this way. You've got infrastructure as code. You can actually open up your processes to more teams and more people. So imagine you are an infrastructure team and you are serving development teams. You can turn this mechanism easily into a self-service. So do they need a new namespace? They can just open the pull request themselves because they see in the code how the code should be structured, how the definition of the namespace should be placed. They can open the pull request themselves, and probably our infrastructure colleague can just have a look, merge it, and run the automation. So this actually decreases the lead time for changes, which I think is amazing for the clients. I mean, for your internal clients. And this can be extended. So I was mainly doing examples on infrastructure side of things, but not necessarily. I mean, with Flux, Argo CD, you can deploy applications. You really can empower the development teams to operate the applications themselves. Maybe you have heard the term shift left. So if you look at the chart, shift left means that you can actually do more activities on top of your Git repository, on top of your code. You can actually start dealing with security concerns. You can do policing on top of the repo, because the state of the repo will be anyway just translated onto the target machines. So this is one of the things that we can relate to when people talk about shift left. So doing most activities early in the flow, because then you get an early feedback, which is always better than the late feedback, right? Typically, if you get feedback later in the flow, you're losing context. It costs you more money to react on that, more time. So that's why we have the infrastructure as code, and there are lots of toolings. I have mentioned Flux and Argo CD as the typical ones if you're dealing with the Kubernetes manifests. When we talk infrastructure as code, we can talk also about, obviously, Terraform for provisioning cloud resources. But we can talk about other tools like even Ansible, Puppet for configuration management, and many other. Right? I'm just picking the most famous ones. So how did the world look like before when we had infrastructure as code, but not yet GitOps? I mean, that was maybe a year ago. I think we started embracing GitOps around the time. It was not truly a Wild West. So we had some organization, but things were not perfect. And what I mean by this is, so an example, we had our infrastructure defined in Terraform, but every time we ran the Terraform code, we saw that somebody did something via command line or ClickOps, probably some tests. They forgot about those. And when we ran the Terraform automation, it just showed, well, there is a list of differences and you should sort them out before we execute the planned Terraform changes. And it was always like, okay, so, who did this? Why it was done? Was it a test? Is it meant to stay forever? Should we persist those ClickOps changes in the Terraform code? I mean, we were able to progress, but there was this little friction. So that was one thing, right? Second thing was to understand who did what. I mean, over time, when, for example, we were dealing with specific aspects, we needed to understand the context. But if the context was missing, we had to find who exactly did what, either in the GUI, and if the person was still available and could remember and provide us with the information, that was nice, but it was not always the case. So, it was a little bit of pain, we had these constant investigations going on. I mean, I'm slightly exaggerating, but maybe you're getting the point. And another thing which was interesting was that, so we had the infrastructure as code, we had automation, but we did not really trust the automation. So what we resorted into was, when we were creating, for example, a new cluster, or we were adding other resources, new applications, we were afraid to run the automation end to end. And why was that the case? Because the automation, when the automation was deployed with the first, for example, Kubernetes clusters, we had version 1.13. The clusters were built using kubeadm and some automation around that. So we did the cluster upgrades. We tried to upgrade the automation as well that provisions the clusters. But after a couple of rounds of upgrades, we were actually not sure anymore whether the automation evolves nicely and on pair with the version of the Kubernetes that we had in a stack. Because, there were often breaking changes. Configuration files have been moved to different locations, and all these had to be reflected in the cluster lifecycle orchestrator. So how it looked like in the end was that we always looked at the automation in a way that it was a sequence of steps, and we were going step by step, looking into those and thinking, well, can we run this step within the automation? Yeah, should be fine. Let's do it carefully. Then we run the step. Then we come to the next one. Yeah, let's skip this one because this one is not that necessary. We can just get along without that one. So we skip that one, and so on. And in the end, maintaining the infrastructure took us more effort than it should have. And then it actually originally did have when the automation was fresh and on par with the cluster level. We actually did not use any high-level cluster orchestrator like Ranger or Kubernetes, or we even did not use Kubernetes as a service. So we truly had our own clusters built by kubeadm, and that's what we had the Ansible automation for. So yeah, that was around that time where we just saw the GitOps buzzword and understood that it could help us solve couple of problems which I just mentioned. But we were of course afraid. We just did not know whether we can easily migrate, for example, to Flux. Yeah. So I just had a short intro here. I'm wondering, Karen, are there any questions specifically on the topic of infrastructure as code, or GitOps as a buzzword?
Yeah, I'm watching actually the chat, and it's very quiet. People are excited and watching, staying in the stream. So no questions so far. I have one question from my side, and it's Git is obviously like very much involved into the whole chain. Are there any Git preferences? Like, we know there are three like major Git platforms out there. One is GitHub, another one GitLab, and Bitbucket is also pretty strong. But Git is a technology that you can run completely on your own. You don't need to be dependent on a provider. So what's, from your experience, like what kind of Git is being involved usually with your customers from your experience?
Yeah, in GitOps you can use any, of course. Okay, so with the two biggest customers right now, we are using GitLab with the first one, Bitbucket with the second one, And for our internal purposes, we use GitHub. So we've got all three covered. And of course, I mean,
yeah, great.
Git being the standard, you can use any. You can plug in to any of them.
Mm-hmm. Yeah, that's actually really great, because this way you have hands-on experience like with all three major Git platforms. But as you said, Git is something what is a standard. There's like the core scope of the commands is the same. There could be some extensions of it with GitHub, for example, some more features or whatever, but the core, it should be the same. And advantage of GitLab comparing other two major platforms is it's actually completely open source. You can run it on your own. You don't on your own premises, or you don't have to be dependent on anyone with this.
Correct. I'm actually curious about the audience, and if I may ask you, folks, on the path from, let's say from ClickOps or basic command line configuration or manual deployments of things through infrastructure as code to GitOps, where are you? Could you just indicate in the chat whether you are, for example, 100% infrastructure as code and you are looking into GitOps, or that maybe you are already 95% GitOps, meaning that there are 5%, there is 5% of your project that are not yet under the GitOps flow. I would like to see, and compare where the audience is. For
That's
example,
a great question. Yeah. Mm-hmm.
I can tell you with the clients. So I have mentioned one enterprise we did 1 year ago. We transformed to GitOps that was on pre-production environments. On production, they are not yet on GitOps. And the other enterprise we are involved with right now, they have actually very, very strong GitOps program. And they are moving their on-premise data center into cloud. And they are planning to be GitOps from day one. And it's like, from my perspective, it's really, they're taking it to as far as it can go in terms of applying these, workflows.
Yeah. Meanwhile, we have a couple of answers, or like at least one answer is there from Jeskirat, and he's writing that IAC infrastructure as a code. That's where he stands right now. So obviously not yet GitOps. And we have a couple of questions here. One is, which is the best self-hosted Git, in your opinion, Bernard?
Yeah, I mean, I'm not a person who would do a deep comparison on these things, but I really prefer GitLab. Yeah, or if we're talking about self-hosted one. Otherwise, I would go with GitHub. Yeah. But I mean,
GitHub is not self-hostable, right? GitHub is provided as a service, right?
Normally, yeah, but I'm not sure whether they have some enterprise offering for self-hosted GitHub.
Yeah, could be.
I'm not sure about that.
Yeah, I'm also not aware.
Self-hosted, definitely GitLab. Bitbucket is not my favorite, I need to say.
Mm-hmm. Yeah, so from these three major platforms, I think, if I'm not completely mistaken, and if I am, please correct me in the stream chat, I think only the GitLab is actually completely open source, and you can download it, host it on yourself as you wish. All other two major platforms, GitHub and Bitbucket, are provided as a service by their providers, but again, should be double checked as an enterprise offering. Maybe there is some opportunity to self-host it. Otherwise, I think there is also the pure Git version, which is not affiliated with any platform. It's just available as a source code. Like is a original thing what Linux Torvalds has developed for the Linux community in the first place.
Yeah, exactly. Okay, so so we spoke a little which problems you can solve by moving into a GitOps based workflows. But how to do that? Yeah, that's a big thing. I've mentioned a few times that your automation should be idempotent. You need to figure that out. Yeah. You need to be confident in the automation itself that it's going to work the way it's supposed to. Yeah. We were not. Yeah, I'm not sure whether our automation was actually idempotent back then, and whether we definitely did not have enough confidence. We had to invest some effort, but it was surprisingly low. Yeah, I mean, I was afraid that it's going to take too long, or a couple of weeks to get there. But I mean, we did it really quickly. And of course, I mean, as usual, when you are deploying some changes, maybe you want to find a side cluster or a part of your environment where you can just crash and burn things, test it there, and then propagate to upper testing or production environments. So, I mean, there are the basic tools which I was mentioning earlier when talking about infrastructure as code. All of them, they have a built-in mechanism for closing these gaps. So you can dry run the intention of the tool, and it's gonna show you which are the gaps that need to be closed. Yeah. But the biggest thing, from my perspective, is a cultural shift, because then people are really forced to go through the GitOps flow, and it implies a change. And people are reluctant to change, right? So for some people, maybe it was good enough. I mean, ClickOps or manual deployments, other types of managing what they needed to manage, and they were happy with it. And they just did not see that, for example, there is a different team or a different group of people that have headaches due to this, right? So yeah, this might be a challenge as well. Maybe it's good to, just to help out a little bit, just to identify a small domain, not necessarily isolated, but a small domain where you say, we are gonna deploy GitOps here, and we will need to stick to that. Yeah, because if somebody else comes from elsewhere, does modifications, the automation triggered by well, we haven't really spoken about the triggers, but the automation will rewrite the changes that the person has done outside of the automation. Yeah. I will speak about triggers here because I would like to tell you a little bit about Flux, because that's the point of this session. So Flux is a software, it's an operator that you can run in Kubernetes cluster, and it's going to synchronize the application on the Kubernetes cluster against your Git repository where you have manifests. It can do this on various bases. So you can implement, for example, Git hooks as triggers for synchronization. We did it a different way. We have set regular polling in Flux to check, regularly for any changes in the source repository. It's an amazing tool. I love it. So what it can do, it can synchronize raw manifests. It can synchronize Helm charts. It can synchronize customization bases and customization actually overlay. These are the three main things it can do. Fourth one, which I haven't really used, and it's sort of going against the infrastructure as code principle. It can watch your Docker registry for new releases and apply them automatically. So it can see that there was, for example, a new Docker image built for your application, and it can apply it automatically. This goes really against the infrastructure as code, and if you decide to go down this path, it's okay because it's simple. It really makes sense at a certain stage of your project, probably. But you're losing all the good things from the infrastructure as code, visibility, audit trail, these things. Flux supports even multi-tenancy, role-based access control, so everything is driven via service account. And a nice thing it can do is a garbage collection. So imagine if you deploy something via Flux, and then you delete half of your deployment from your source repository. Flux will notice that. It will accordingly remove that particular part from your clusters as well. Amazing stuff. Maybe you have seen there was some noise probably when new Flux came out. So we did a migration. Well, we applied GitOps thanks to Flux version 1. Now there is Flux version 2, which relies heavily on the custom resources in the cluster. And in general, this is a good thing, but it has some downsides as well. Flux version 1 was easier to deploy. But I will be showing the demo, and I'll be talking about Flux version 2. I'll just make a note to Flux version 1. So for example, if you are managing your manifest using something else than the Helm or Customize, for example, if you are using YTT, KSONet, JSONet, Grafana Tanka, it was way easier to work with Flux 1 than it is with Flux 2. So I'm just showing you where to look at if you want to start with Flux, and for example, you have your source repositories manifested using YTT. Okay, so I'm going to show a quick demo what Flux does and how it does things. I will share the link to the repository at the end of the presentation. It's going to be on my GitHub. Well, it already is on my GitHub. But let me show you what we have here. I have built a GKE, so Google Kubernetes Engine Cluster. Kubernetes is a service on Google Cloud Platform. For that, I used a Terraform code, which is here. There are some secrets to the Terraform code. We will deploy Flux in there. By the way, maybe I should.
Yeah. Oh, yeah. That's really nice. Thanks, Bernard.
Okay.
Better.
Perfect. So the cluster is already running, so I use Terraform for that. We will deploy. Well, we have already deployed Flux. I got this prepared as well. No, sorry. I will deploy Flux. And Flux will look into GitHub and will deploy an application, right? So maybe we start from the application side. What are we going to deploy? This is a famous guestbook application. Maybe some of you know it who have been through the Kubernetes documentation. It's a very simple app written in multi-service fashion. I've got a customization putting all these things together, but it doesn't do anything. I mean, I'm going to show you. This puts all the manifests together. Yeah. This is what we will be deploying. We will be deploying it from the GitHub repository. But in order to do that, I'm going to show you the Flux deployment. Well, I should say that there is a a very nice Flux command line interface, which will deploy and install Flux for you in a non-infrastructure as code fashion. Right? It's going to be a command line, and it's going to generate all the YAMLs directly on the cluster. It's going to bootstrap everything for you. So it's really, really good for proof of concepts, for demos, and so on. But here I would like to show you a little bit deeper, to see what's behind the curtain, behind the CLI. So there are a couple of things, a couple of CRDs that Flux defines. What's important for the basics? We need to define Git repositories so that Flux know where the code is being pulled from. In our case, we will be dealing with customizations. So, showing Flux where in the repository to look for the customization code and how to build it, basically. Then there are a couple of other things. So the Helm charts are, objects that are going to be, so the Helm star YAML or Helm CRDs are going to be used if you deploy Helm charts. The buckets are here for you in case you don't want to host your code on Git, but if you want to use storage buckets, like S3 on AWS. Alerts are good for alerting, right? Providers are good for notifications. So, for example, if you want to be notified in Slack or Microsoft Teams that the Flux reconciliation has failed for some reason, maybe there is a bug in the repository, you will define a provider for that, and thanks to the provider, you will be made aware. And there are receivers. That means that Flux can act not just on inputs or just on, for example, periodic reconciliation of the Git repository, but you can use custom webhooks so that you can build in Flux into your more complex tooling and workflows. So you can define custom webhooks and trigger Flux for reconciliation. That's about the CRDs. I'm going to apply everything I have here. So we've got the Git repository and some basic configuration. Of course, RBAC, not worth talking about it. Controllers are just instances of the CRDs I have mentioned earlier. So let me just build and apply everything. Oh, I just had it running, so okay. I'm not going to delete this and reapply again. Well, I'm just going to check the import. Normally, if we have a look at Flux system namespace, we see the relevant controllers. We see the customized controller because that's the one we are using right now. I'm going to check if we have repository definition. We don't. We don't have any customization object either. So I'm going to apply them manually, but first let's have a look what's inside. So this is a Git repository. It defines where the application is taken from. So going from the bottom to top, this is the repository we are looking at. This is where the Flux the whole demo for today is prepared. You can suspend the repository if you need to for some amount of time so that the changes do not propagate, and you can use this switch for that. Of course, in order for Flux to pull the repository, it has to have an SSH key, so that's a secret. And you specify which branch You can actually specify a tag here that you want to be, synchronizing. Of course, important is to set the interval if you want to do it periodically. And this is just a Git implementation. There are 2 Go Git implementations you can choose from. So I'm going to apply the Git repository. And we can have a look. It has been really created. And it has been already synchronized. We've got the status true. So we can actually use it, but nothing is happening yet. I'll show you the namespace where the application should be running. We have nothing running there yet. So we enable the deployment by creating the customization custom resource, which tells us, again, there is some periodic interval, but this is an important thing. It tells us where from the repository it should take the manifest from. So we are taking this from the application repository. And this way you can actually see that you can have multi-tenant deployment in a way that you can have a single repository and deploy multiple applications out of that one, all coming from a different folder. And of course, we are referring to the repository we have just deployed. So prune, this is a feature for garbage collection. And I'm going to showcase that one. So let me apply YAML. And what we will see is that synchronization loop was really quick. So as soon as we created the customization YAML definition, it started pulling data from the Git repository, and you see our application is coming to life. So we can, if you're interested, we can have a look. We have some services. We can port forward to the front-end service. And we can have a look at the guest. So I'm going to leave a message here. But imagine you want to do a change, right? So this is just how we deploy the first application version. So I've got it prepared. Let me open it up. I'm going to stop port forward. For example, you want to deploy the application live. We are using, you see, cluster IP services. Maybe you want to open it to the world by using, a public load balancer with a public IP, so that somebody can access the application from outside. And this change we are going to deploy through the GitOps fashion. So there is a pull request which I prepared. Let's have a look inside what it carries. So okay, just ignore the bottom part. It's just a new line addition. But here we are redefining the service from cluster IP to the load balancer. So it's going to be publicly achievable. So we've got the merge request, and we say this is a nice one, and everything is fine. Your colleague had a look, and everything is fine. Let's merge it. So we have merged this, and let's watch the services. And in 2 minutes, when the change will be picked up, because we have 1 milli delay on the, or 1 minute loop period for checking the Git repository, and then customization is also happening on top of that in 1 minute period. So in up to 2 minutes, we should see the front end being changed from cluster IP to load balancer, getting some external IP we can access. So maybe this would be a good time to check whether we have any other questions till now.
Yes, let's check. Mohammed is asking, is your GitHub repo public? I think so. I just saw from your demo that it seemed to be a public repo, right?
Correct. I'm sharing the link at the very end of the presentation. It's public. You can find it on my profile on my private GitHub. Sorry, personal GitHub.
Yeah, we'll make sure to share it also with everyone after the session, actually. So don't worry about it, everyone. If you want to look into particular configuration files or scripts, they will be there in Bernard's repo, open for everyone.
Perfect. So we have seen that the change has been picked up. The front end service has been changed to a load balancer service, and now it has an external IP address. So we should be able to access it, right? But here we are. Okay. So all worked well, and let's showcase the cleanup, the garbage collection cleanup functionality. So if we now decide to, let's delete the customization description for this project. We see that Flux is reconciling the situation and is steering everything automatically down. And I think this is nice, right? So we can get back to the presentation. This is just an overview of what has been done. So there is a source controller that's plugged into my GitHub. We have configured everything through CRDs. This is stored in the Kubernetes at CD, accessed via the API server. The customized controller reads the content of the repository through the source controller, reads the configuration of our application, and just deploys and manages everything. I have also prepared a small part about how can we deal with secrets. I'm not sure whether I think we are not really that well on time. What do you think, Aaron? This might be for another 5-6 minutes.
Yeah, the topic of secrets looks really and sounds really interesting. I think we can definitely jump into it. Don't worry about the time. We just have one question in between. Let me read it. Elias is asking, is there any place to learn in more details about Flux? Any lab or course? Thanks. So Bernard, what would you recommend if someone want to go deeper? It seems like you are super excited about Flux, and this is not for a good reason. How about learning about it? What are the resources for it?
So the official Flux documentation, I've got it open here somewhere here, is amazing. So I don't know whether you are interested in the very basics. So Get Started is prepared very well. As I mentioned, the how-to guide uses the Flux command line interface, so it abstracts all the stuff I have been doing with the manifests. So this is very easy to pick up on. You just provide the repository, some access keys, and off you go. You build your stuff very quickly. It's really good. The Flux documentation is amazing. If you want to go down, to further and advanced things, I haven't mentioned that, but Flux is built on GitOps toolkit. So that's basically the thing underneath and the API definitions that power all the logic and the workflows. And you can extend the GitOps toolkit. So as I was saying, that in case you were managing your manifests with, for example, YTT, with applying Flux, you would not be, okay, you can get around, but it's not going to be as smooth as compared to, for example, the customize example that I just showed. But you can extend the GitOps toolkit and you can add the YTT controller in there, and you should get a native experience with that. And the way how to do it, you can have a look into the dev guides to do that.
Okay, great. Thanks.
Perfect. So I don't want to spend like much time here because the topic of secrets it's huge on its own. But I just want to say that in case you are not using dedicated secret management system, and even in case you do, you might find interesting that Flux supports sealed secrets from Bitnami and Mozilla SOPs. So these are ways how to store. Well, both solutions allow you to store secret information in your Git repository alongside your application manifests in a secret manner, so that you are not worried about leak unless your keys leak, right? But still, Flux internally can decrypt the content and apply as expected on the target cluster. So you store your secret in an encrypted format in your Git repository. You wanna, get it to your cluster as a proper secret. So how is that done? Of course, like there is some automation doing that. So there is a key that fits into the automation that decrypts the content of the secret in your repository, and that's how it's applied in your cluster. Well, in the case of Mozilla SOPs, this is amazing stuff, is that Mozilla SOPs can use for decryption of the content any key management system that you might be using. Yeah. So in case you use HashiCorp Vault, GCP, KMS, AWS KMS, Azure Key Vault, or even if you manage keys yourself with a GPG or Edge, Mozilla SOPs can plug into here and do the seamless secret decryption on the way to the cluster or to your repo. So in both directions. And this way, well, this is supported. This is built into Flux. The support for Mozilla SOPs is built into Flux. So you can actually end up, and this is what we were using, you can end up hosting your secret files in your Git repository without having the need for dedicated secret management system. But you can also reuse what you have here. And if you apply SOPs on top of it, it makes you cloud agnostic. It should not be a problem then to switch between the cloud providers, right, if you need to. So yeah, it was just a small detour because I think it's worth it. This was one of interesting topics we were digging into when we were using Flux. So that's why I spent a minute on the secrets. So how to start with Flux and how to be successful. I don't know. There could be many ways how your collaboration workflow looks like now. But what we found out is that in case you have already Flux deployed, or you are thinking like, how am I going to introduce new changes to the infrastructure or to the application if I've got my Flux already deployed and it's syncing the Git repository? And how can I test something, in a sort of a sandbox mode, or in a way that ideally, okay, let me take it from a different angle. When we were managing our clusters with Flux, our typical workflow was that we opened the feature branch. We did some development in the feature branch, but then we wanted to test the feature branch against the cluster. We wanted to see the change on some testing environment, to see the effect. And of course, the cluster was being synced against, for example, a master branch, so a different one. So there are multiple options how you can solve this problem. So for example, applying your changes, your work in progress on a test cluster temporarily. Yeah. So what you can do here is that you can suspend the synchronization for some time. You apply your changes manually, and you don't have to worry that the Flux would revert them by the time you finish your testing. So that's one way how to do this. The second way how to do this is that you can point Flux to your specific branch in your repository, and this way the changes will be applied on the cluster, and you can see how it behaves. You can run your tests, and based on the results, you can then decide whether you want to merge your feature branch into master or not. But this creates a problem, because if you suspend the reconciliation, or you just modify the destination, or in other words, the branch from which you are taking the manifest, you are introducing a drift, right? You are changing the state, and Flux is not working the way, it's not pointed to the master branch anymore. And this might be of a surprise for somebody. And in order to avoid this, so that we forget, Flux suspended for too long, we introduced cron jobs, daily cron jobs. Every morning, we just restart Flux in the default manner. And this way we know, and it was sufficient for us. I mean, this way we know that whichever temporary modifications or Flux suspension being done will be terminated, and Flux will be returned to its original state and targeting the master branch every morning. Yeah. And then you have to monitor the situation. For example, it can happen that you introduce a change in your repository which breaks the deployment, and Flux will fail to build the deployment and to deploy it. You need to be aware of that, right? You just don't want to go and find out by surprise. Yeah. So that's another recommendation I would do. Don't forget about this. And the last one would be that you don't have to push the boundaries too far. Sometimes it's really reasonable to end at 95% or 99%, meaning that it's completely okay if there are areas in your environment which are not covered by GitOps or by Flux. And this is perfectly fine. An example can be, so imagine you are building your software and you open a pull request, and this pull request has a pipeline that automatically does integration testing. So for example, it creates a temporary namespace in your cluster, it deploys your new version of the software there, and it runs some tests against this. It's completely okay not to cover this workflow with GitOps. I mean, just leave this temporary namespace out of GitOps. It's completely fine. I think this is better. I have seen people trying to cover it under the GitOps umbrella. Oh, no, rather not. I mean, maybe you find a good way. We haven't. Talking about the alerting, you can alert basically on all the popular channels you can plug into, as I mentioned, Slack, Teams, Discord, whatnot. Just plug in somewhere. Yeah, have a visibility. Don't forget about this. It really helps, and it increases the iteration speed. Yeah. Okay, where to go from Flux? So Flux is a tool, as you are by now aware of, if you haven't before, for keeping the manifest in sync. But you can go further. You can apply GitOps on your infrastructure provisioning, on your Terraform code. It's not easy. Yeah, there are some questions, and there will be some hurdles you would need to sort out, but you can do that if you want, of course. We actually did not do this. I mean, we thought about it, we just put it on a to-do list, but we did not get there. I know other people did, and they're happy with it. You can also do configuration management via pipeline. So this is something that has been done. We use Ansible for configuration management of the clusters, and we just created a pipeline that is triggered periodically, but it can also be triggered on commit, no problem. And it runs every time then and synchronizes the destination against the Git source. And it's working amazingly well. I mean, really happy with doing so. And you can also cover with GitOps other systems and workflows you have in your companies. If you use, for example, some tool like Captain for release management, you can do the configuration surprise by GitOps, right? Or policy management as well. So I don't know, Karen, if there are any other questions in the meantime.
Yeah, there was one question which another member also confirmed that he would be also interested in it. So the question was comparison of Flux against Argo CD. But that's from your previous slide, we learned that these are two tools which are usually used frequently. So have you any experience with Argo? Is there any, like, you can just give a short answer, you know?
Yeah. So if you are starting, the biggest difference is GUI, of course. I've seen that Argo works better for developers. They tend to like the GUI a bit more. People from the cluster operations side of things, they prefer for the infrastructural content to be synchronized with Flux. I think Argo is slightly more comprehensive. Flux is simpler, but really powerful as well. And I've got the impression that Argo, in the corner cases, might be a tiny bit ahead of Flux. Yeah, I think you can achieve slightly more with Argo. But if you are looking for some specifics, I think you really need to deep dive because they can differ underneath. Yeah, as far as I know, for example, it will be very difficult to plug Argo with Mozilla subs. Yeah. But if you're starting and you don't know where to start and you like GUI, go with Argo. If you can also, okay, Argo also has a command line interface as well. But I think Flux is slightly lightweight, more lightweight. So if you want to go down that path, you prefer better readability, maybe go with Flux. I mean, this is a biased answer, so take it with a pinch of salt, please.
Okay, great. So yeah, thanks, Bernard. We don't have much questions until now. If there will be any questions later on, everyone feel free to ask them in the on GitHub. There is a comment section. Bernard is also reading it. Probably Bernard can follow up with the answers there. But for now, I want really to thank Bernard for this amazing presentation. We have meanwhile 19 already. Okay, 19 submissions for feedback submissions, which also will make you yeah, you will be considered for the raffle, which we will run right now. I will go ahead and share my screen now. Just let me pick the right tab for it. Here we go. So this is a wheel of names. Here are all the names of 19 people who have submitted the feedback form. Yeah, I think everyone can see my screen now. I shuffled it a few times. Very fair draw. And we will just go with the first winner. It's Sad. Congratulations to Sad. Bernard, can you actually hear the audio of the and everything? It's not always working, actually.
This time it is. So congratulations.
So once there is a winner, there's some cheering going on the website, but I always struggle to make it work for some reason. I don't know. But it's okay. If it's silent, then it's silent. No worries. We will go for the second winner. So we have 10 winning spots. Just sometimes Ihor is the second one. Congratulations to Ihor. To the next spin. Before it, we will shuffle a couple of times to make it even more fair. And the third winner is Bitan. Questions to Bitan. Let's shuffle one more time. Seems like Anupam is the fourth winner. Congratulations to. Okay. One more time. Okay, we have the fifth winner, who is Moises. Thanks to you, Moises. Next spin. Okay, so Mohammed is the sixth winner for today. Congratulations. And let's see who is the seventh one. The seventh winner is Nizar. Let's shuffle a couple of more times. Suman seemed to be the eighth winner. Two more winners left. Let's go. Okay, Shashi is the ninth winner. We have one more spot. Shuffle a couple of times, and let's go for the last spin. Hey, Mario is the 10th winner. Congratulations to Mario. Just in case if winners will not respond, I will get in touch with everyone via email. Let's pick the 11th one if we will have in like some free spot later on. It's Srinivasa. Congratulations to Srinivasa. I mean, if it will work out. And the 12th person here is nice. So I guess we have the winners for today. Again, thanks for the prizes as well to Bernard for organizing the prizes for this session and for giving the presentation. Okay, cool.
It was a pleasure.
So that's it for now. Yeah, go on.
I just wanted to say that don't hesitate to reach back if this topic interests you any further. I'm always happy to talk about these things because I mean it's a pleasure. We truly enjoy doing GitOps and all the things around that.
And that's great to hear your experience, how you share it, and what's you're actually experiencing while doing it. We would love to have you for another session, probably already during the next year. But we will also make sure to share all the information, your slides, if you're okay with sharing them, and also all the links to your repository and your social profiles. Make sure everyone to connect with Bernard and stay in touch.
Thank you for having me.
Thanks, Bernard. And thanks everyone for attending this call today. So wishing you to stay safe and all the best, and see you next time.
Take care. Bye-bye.
Bye-bye, everyone.